Alrighty, kiddos. Here we're going to finish up our set of notes with a couple example problems. So first one here, we are going to find the probability of flipping 3 coins and having exactly 2 of them land on heads. No more, no less. So this is actually an example problem for the binomial distribution that we were just talking about. And so here we are looking for the probability of getting 2 heads out of the 3 coin flips. And so if you remember, here I'll go ahead and actually write it right here. So we have probability of R things occurring is equal to N choose R times P of R times Q of N minus R. So that's the equation that we are going to be using for both these example problems. And so in this case, our N is going to be 3 and our R is going to be 2 because we are flipping 3 coins and we're trying to get 2 heads. So here we got 3 choose 2 times the probability of the thing we want to occur happening. So probability of success, which it's a coin flip, they're both 50-50, but we're looking for heads. Probability that is 0.5. And then raised to the rth power, so here it's going to be 3, so we want 3 heads times the probability of it not happening, which is it landing on tails, which is also 0.5, raised to the n minus r power, which n is 3, n is 3, r is 2, so 3 minus 2 is 1. Alright, so here we can break this down. We have 3 factorial divided by 2 factorial times 3 minus 2 factorial, which this right here, 3 minus 2 is 1, and then 1 factorial is just 1, so really this is 2 factorial times 1 times 0.5 raised to the 3rd power times 0.5, because 0.5 raised to the 1 power is just itself. So here, then you go ahead, punch all that into your calculator, scroll on down a little bit, we get the probability of getting exactly 2 heads from the 3 coin flips to be 3/8, or if you want to do that as a percent, 37.5. Alright, so there is our first example problem. And so here, move on up to our second one. Number 2, they're asking us to find the probability of rolling 2 dice 6 times and the dice pips adding up to 7 exactly 1 time. And so when it says the dice pips, that just means the number on the dice. They're called pips. So basically you're rolling 2 dice and trying to get both of them to add up to 7. And it wants us to try to get that exactly 1 time just from rolling the dice 6 times total. This again is also binomial distribution, just like the previous problem. So here we have, give me 1 second. In this case, I'll go ahead and write it out. N equals 6, because we're rolling them 6 times. We're trying to get a 7 1 time, right? And so what we're really looking for is the probability of just 1 7 out of the 6 die rolls. Boom. There we go. That's what we're looking for. So here, probability of 7, I'm going to shorthand it, is equal to N is 6, R is 1. So we have 6 choose 1 times the probability of a success. So rolling a 6 rolling a 7, or getting the 2 dice to add up to 7, is actually a 1/6 probability. And we want that to happen 1 time. And then we're going to multiply that times the probability of it not occurring, which in this case is going to be 5 out of 6, which if you're wondering how I got that, we know that the probability of it occurring is 1/6 of a chance, and so the probability of it not occurring is just 1 minus 1/6, which ends up being 5/6. And since we are doing 6 rolls total, it's going to be n minus r, which is 6 minus 1, which ends up just being 5. So here, going to expand that out. We got the probability of rolling just 1/7 out of the 6 die rolls. Is equal to 6 factorial divided by 1 factorial times 6 minus 1 factorial times 1/6, because 1/6 to the 1 power is just 1/6 times 5/6 to the 5th power. So once we have that, again, 1 factorial is just 1, and then 6 minus 1 factorial is just so this is just the same as 5 factorial. So really we have 6 factorial divided by 5 factorial here times all this over yonder. Punch all that into your calculator, and you should get something around. Ooh, that was a bad 0. Sorry. I apologize. %40.188%. Something around there. Boom. Alright, there is example number 2. Hopefully that helps. Remember, I will always be in my virtual office hours if you need more help or explanation. That is it for the set of notes. See ya.